for 2 minutes, okay, so that more students can join us. Okay. So can you hear me? Am I audible, students? Yes. Okay. Fine. So let me start my screen share. Okay. I hope you are able to see my screen. Okay. Okay. Fine. Then yesterday we have done up to your chemical characteristics, right? Uh, Physical characteristics, chemical, then biological, and we have completed your waterborne diseases, right? So today we will move to your the important part of your chapter, that is your treatment of water. Okay. So till now, whatever we have studied, like we have studied about demand. Yes, then we have known how means how what are the types of demands. Then we have checked the quality of water by knowing the characteristics. Yes, so the water. Now you have checked the characteristics and you have found that these waters are having permissible greater permissible limits. I mean it has a value that is not under the permissible limit, and now we need to treat that water. Okay, so obviously, before supplying the water to the public, that water it has to be aesthetically safe, and it should have a good. You can say it has a good. It should have a good appearance also, and it should be attractive to your human taste and tongue. Okay, so we need to treat the water, and the treatment will depend upon what means about the it will depend on the quality of the water. If it is more if it is more dirty, or it needs more treatment, then obviously the treatment load will be more. Okay, so basically in your treatment plant, there are different steps by which the water is being treated. Okay, so here are the methods you see. These are the methods. Okay, these are the methods by which your treatment of water is done. Okay, so first one is your screening. Then plain sedimentation aided with coagulation, filtration, disinfection, aeration, softening, and miscellaneous treatments such as fluoridation, recarbonation, liming, desalination, etc. Okay, so these are the different steps, and you should go step by step. Okay, like it can't be like the first step will be softening, okay, or the first step is disinfection, not like that. You have to go it serially as it is written like here. Okay, the first and foremost step of your treatment of water is screening. Okay, so first, uh, let us see, or you can please note it down. At least you note it down the these points. Please write down the points. You have a copy with you. Please write down the points at least. Then it will be later. It will be easy for you to see. You write down the methods of purification of water. And then you write down the steps: screening, plain sedimentation aided with coagulation, filtration, disinfection, aeration, softening, and your miscellaneous treatments. Write it down. I'm giving you 2 minutes to write down. And keep on writing. I want to tell a brief about all these points. Okay, all these methods. Just one line I would like to add. Okay, suppose what happens in screening is that you have the what in river, or in river you can say, you can see some polythene bags. Some branches of trees, animals, or you can say sticks. Okay, then some aquatic plants, all those things are they are floating in the river. Okay, so screening is a process that removes your this large things. Okay, large suspended particles it removes. Screening, the process of screening is sorry, the work of screening is to remove the all the big and visible things. Okay, all the large suspended or floating the things that are seen. Okay, so after the the these things are removed, the coarser suspended materials are also there. Okay, and that coarser materials, it can be removed by your sedimentation. Okay, the second is your sedimentation. In that sedimentation, plain sedimentation, what is done, the coarser, the heavier particles, you can say, those are being removed. Okay, then the sometimes what happens, the bigger particles, they settle down because the specific gravity of those sediments, it is greater than that of water. So obviously if you keep that for some, in a still position for some time, though, so that particles will obviously, they will settle down. Okay, but what happened to those that whose specific gravity is lighter than water? Okay, that will obviously, it will not settle down easily. Okay, that will keep on floating. So to remove all those, those lighter particles, what we do yeah, is that we mix, certain chemicals with the water. Okay, and those chemicals are known as your coagulants. Okay, so that process, in which we remove the suspended particles that are very lighter, it is known as your sedimentation aided with coagulation. Okay, then after you remove those particles, you know uh, we have to filter the water. Okay, now we have to that you have added some chemicals in your coagulation process, so that chemicals we need to remove it by the process of filtration. Clear? So after you do the filtration, then that water, it might still contain some pathogenic bacteria. Okay, so that pathogenic bacteria, it is removed by some adding chlorine to it. Okay, when you add chlorine or certain chemicals, that means your pathogenic bacteria, it is being removed, and that process, it is known as your disinfection. Okay, so after your disinfection is done, means you have added chlorine, so that water, it might not be suitable for our human tongues, because there will be some odor. Okay, so to remove that, we add some again some chemical compounds, such as activated carbon is used, or some ozone is used, and that process is known as your aeration. Okay, and now, after, since you have the now the taste is okay, you have added some activated carbon or ozone you have added, so the water now, it will become hard. Okay, it will become hard, and so we have to now soften the water, and that process is known as your softening. Okay, and now, after you have done softening, after the hard water has become soft, now the resulting water, it may be given further treatment. Okay, such as you can say fluoridation. It's written there, fluoridation you can do. Fluoridation is done for controlling, you can say, that this is called your dental caries, okay, for your teeth. So fluoridation treatment is done. Okay, then your liming is done, that means adding of lime, okay, to control the acidity, or you can say corrosive action. Okay, then recarbonation is done. Recarbonation is what? Adding of carbon dioxide, okay, so as to prevent what? Deposition of calcium carbonate. Okay, then, and desalination is done to remove the excess salt. What is desalination? Desalination is to remove the excess salt that is present. Okay, so this is, as a brief, okay, it is about your treatment of water. So we will this is just a short description I have given, but within this, there are we have to learn more. Okay, so let us. I hope you have finished writing. So we will proceed first to screening. Okay, screening we will proceed this one. So first, I would like to show you how a screens look like. Okay, this is a view of plan section and a prospective view of a fixed bar type screen. Okay, you can see here, this is a screen. Okay, then again one image I have, this one you can see, this is a screen. Okay, so here, this part, this part is your screen. Okay, it is called screen. And so let's see what a screen does. So screening, I already told that it is the first step of your treatment of water. So in any treatment plant, the first step is to provide screening. Okay, so what does a screen does? It collects the, or it first of all, your screening, it is provided before your intake works. Okay, screens are provided before your intake works or before your pumps. Okay, so screens generally there are of two types of screens. Number one is your coarse screen, and the number two is your fine screen. So from the name itself, you can know that what is a coarse and a fine screen. So coarse is basically the screens that are having the the gap between the rods. The screens are made of parallel iron rods. Okay, so the gap between the rods are it's bigger than your fine screens. Fine screens have a very very small minute openings. Okay, you can say minute openings it have, and coarse screens have big openings. So what is done? Your coarse screens, those are used for used for your collecting the big floating suspended materials, like your, as I already said, like your trees, polythene bags, animals, aquatic plants, those are floating, the big things, sticks, branches of trees, all those things. It stops. Okay, it stops all those things, it carries all those things. So and fine screens are to it carries the fine suspended solids. Okay, so screens are generally provided at an inclined position. Okay, it is generally kept at 40 to 60 degree to the horizontal. Okay, why it is so? Because it will if it is means if it is kept horizontal, it will increase the flow area, and if flow area is increased, the the flow velocity, it will reduce, and as a result, more suspended particles it can carry. Okay, or sorry, it can stop, or it can, the more suspended particles it can collect. Okay, so you remember that your screens are always provided at 45 to 60 degree to the horizon. Okay, so nowadays actually your core screens are generally used in comparison to your fine screens, because you see fine screens have very minute spacings, or it has very small openings. So what happens, the fine screens, it gets clogged very frequently. Okay, it gets clogged very frequently. So what happens nowadays, your fine screens are normally not used. Okay, and the work of the fine screens, it is done in your next step, that is your plain sedimentation. Here, so here nowadays in your treatment plan, coarse screens are used, and the coarse screens, it it collects the suspended, the big suspended particles in the process of screening. Okay, so this much is about your screening. So I guess you can write the notes by yourself. Okay, you can, I have explained what points to be needed to be included. You read this, and you can write the notes by yourself. Okay, the important points, you write it down. Okay, so um okay, so screening is done. Okay, so your screening is done. You have collected the large suspended particles. It's done. But what happens to the finer suspended particles? Okay, the finer suspended particles. What will happen to them? So you see, the suspended particles. So most of the suspended particles, they have a specific gravity that is greater than water. Okay, so what is done in your plain sedimentation type 1 settling? What is done here? In that in, in that tank, or you can say in that yeah, in the tank, you can say, the water, it is kept in still position. Okay, you can say for 24 hours the water is kept in a still position. So what will happen, since the impurities, it has a specific gravity greater than that of water, so in that still position for 24 hours, the impurities, the suspended impurities, it will settle down slowly. Okay, slowly the impurities will settle down, so that impurities, after it settles down, it can be removed. Okay, it can be removed. And so this is the idea behind your plain sedimentation, that we need to keep the tank in a still position. We need to we need to keep the water in a still position in suspension, and so that the impurities whose specific gravity, it is greater than that of your water, it will settle down slowly. Okay, and one more thing, and the tank, okay, in which the these impurities settle down, it is known as your settling tank. Okay, or you can say sedimentation tank. Okay, and one more thing, in environmental engineering, when we talk about time, okay, when we talk about time, like I am talking now, that we have to the time taken by the suspended impurities to settle down, so that time, it is not only known as only time, it is known as your detention period. Okay, so in environmental engineering, you have to remember this term, the period, the or the time, that is, it is written here, you see, the average time, this you see, the theoretical average time for which the water is detained in the tank is called your detention period. Okay, so the time up to which the suspended particles, it is, kept in a still position, so that the impurities settle down. Okay, so that time is known as your detention period. You will not say it is time, but you will refer that term as detention period. Okay, so this is your the idea behind your plain sedimentation. Okay, so here you can here you have known that the impurities whose specific gravity is greater than that of water, they will obviously settle down. Yes, they will settle down, but what will happen to those impurities or those suspended particles whose specific gravity, it is not greater than water? Will that settle down? Obviously not. Okay, since it has a specific gravity lower than that of water, that is 1, so that suspended particles, it will keep on floating, it will not settle down. So what we will do about those impurities, what can be done to those impurities? Yes, so our next step is your what? Sedimentation aided with coagulation. Okay, so sedimentation aided with coagulation, we will not study today, because the notes I have, I don't have it now. Again, I have to click photos and then I have to upload. Okay, so today we will learn up to plain sedimentation only. So basically, I'm just telling you in brief that what is done there. In sedimentation aided with coagulation, some chemicals are added. Okay, and those chemicals are known as coagulants. Okay, so what it does, it makes the impurities heavier. Okay, it combines that chemicals, it combines with the impurities, and the impurities, the suspended particles, now it becomes heavy. Okay, and when it becomes heavy, it will automatically settle down. So the work of the coagulation is that one. So later in next class, we will learn more nicely about that, what coagulants are being used and all. Okay, so yeah, for plain sedimentation, you have known the idea. So what is the theory behind your sedimentation? Let us see. Okay, what are the theory of sedimentation? You see, first one, the velocity of flow which carries the particle horizontally. Okay, so as already I told, the greater the flow area, the lesser is the velocity, and hence more easily the particle will settle down. see in your this one in the plain sedimentation, that these are the theories, okay, why the particles are being settled down. So here the area, the greater the flow area, okay, so the greater will be the flow area, the lesser will be the velocity, and hence the particle will settle down more easily. Number two is your the viscosity, okay, so the viscosity, the viscosity of water, it varies with inversely with temperature. Okay, so warm water is less viscous than, and therefore offers less resistance to settlement. Okay, so but it is inversely to your, it varies inversely to your temperature, remember this. Okay, and number three is your the size, shape, and specific gravity of the particle. So the greater is the specific gravity, more readily the particle will settle. Just now I'm telling that only. Yes, so since the impurities have a greater specific gravity than water, so the particles are more readily they will settle down. Okay, so this much is about your theory of sedimentation. Now you have to remember one formula, okay, the settling velocity. Okay, the settling velocity formula, you need to write it down. Please write it down, this formula. Okay, this is a Stokes law. Okay, the settling velocity, it is expressed by Stokes law. Then you have to remember this formula for d is smaller than 0.1 mm. Please write down this formula in your copy. We will do one numerical regarding this. Also, you write it down, this one, for viscous flow and small sized particles represented by Reynolds number less than 0.5. You just write down the formula, then you write for D is, this formula is suitable for D smaller than 0.1 mm. We will see what is D, what is Z, all these things we will see in the next page. First you write down, or you take a screenshot. Okay, so next page, let us see. Let's see here, where your Vs is your settling velocity. Okay, settling velocity. V is your diameter of the particle in meter. Capital G is your specific gravity of the particle. Okay, then the formula is given, this one. Then mu is your kinematic viscosity of water in meter square per second. Okay, you just remember these notations. You have to remember. Okay, these notations you have to remember. Now you take a screenshot, please. Again, you have two formulas. This formula was your for D is lesser than 0.1 mm. Yes. So next one formula again we have is this one. This one. This is for D is greater than 1 mm. Okay. And also this one. This is D lies between 0.1 mm and 1 mm. Okay, you have to remember these three formulas. Settling velocity formula. Okay, these are settling velocity formula. Remember this formula, and the formula just now I showed. Okay, so let's do a numerical. Okay, regarding this formulas. So this is your numerical. this is your numerical. You see, find the settling velocity of a discrete particle. Okay, so discrete particle. What do you mean by discrete particle? It is that which do not the particles which do not change their size, shape, and weight. Okay, and one opposite term of discrete particle is also there, and that is known as your flocculated particle. Okay, so flocculated particles are those which change their size, shape, and weight, and then it loses its identity. Okay, so discrete particle means it do not change its shape and size or weight. Okay, so you see, find the settling velocity of a discrete particle in water under conditions when Reynolds number is less than 0.5. The diameter and specific gravity of the particle is 5 into 10 to the power minus 3 centimeter and 2.65 respectively. Water temperature is 20 degrees Celsius. Kinematic viscosity of water at 20 degrees Celsius is equal to 1.01 multiplied by 10 to the power minus 2 centimeters square per second. Okay, so this is your question. So what things are given here in this question? Your Reynolds number is given as 0.5, sorry, less than 0.5. It is mentioned. Okay, it is less than 0.5. Then your diameter and specific gravity, it is given as 5 into 10 to this one and 2.65. Okay, then water temperature is 20 degrees Celsius given, and kinematic viscosity it is given this much. Okay, so we just got the formula where D is your less than 0.1 mm. Okay, diameter it is given as 5 into 10 to the power minus 3 centimeter. That means if you convert it to millimeter, so obviously it will be less than your 0.1 mm. Okay, so we can use the formula that is used for D less than 0.1 mm. Okay, so like this you have to see which formula we will use. The diameter you see, and then you use that appropriate formula. Okay, so this is the formula and everything is given here. Your specific gravity capital G it is given, D is given, so you have converted to it to millimeter. Okay, then mu kinematic viscosity it is given. Small g, you all know that it is 981 centimeter square per second. It is in centimeter, they have written, that's why 981, otherwise it is 9.81 meter square per second. So you put this in your formula. Okay, you put it in your formula, then you will get your settling velocity. Okay, you will get your settling velocity. So answer, it will come approximately to be 0.022 centimeter per second. Clear? It's a very easy numerical. You can take a screenshot, or I will provide you this PDF later. Okay, so let me quickly take the attendance. Roll number 69.
Yes, ma'am.
Okay, 51.
69.
Okay, 69. 51.
Present, ma'am.
Okay. Then 51 to 60, who is present? Up to roll number 60, who is
Present,
present?
ma'am.
Yeah, Guneshwar, I have given you present. Other than you, who is present? Up to roll number 60. Uh-huh. 52, 53, 54, 55, 56, 57, 58, 59, 60. Who is present? No one. Okay. 61. Arif Khan.
Present, ma'am.
Okay. 62.
Yes, ma'am.
Okay. 63.
And 61 is present, ma'am.
Yes, ma'am.
63 present.
Yes, ma'am.
Okay. 64, 65 absent. 66. Pankaj.
Ma'am,
Ma'am, did you
66, ma'am.
mark 61 as present?
61 present.
Yes, ma'am, 66.
66. Okay.
59 is present, ma'am.
Yes, you are overlapping. I cannot hear you. Just wait.
Ma'am, 66.
Yes, 66 I have given present. Then 67.
Present, ma'am.
59, ma'am. Ma'am, 59.
69. Okay. Then 68.
Ma'am, 67.
67
Present,
present.
ma'am.
68 Motiur present.
Present, ma'am.
Okay. 60, 70. 71.
Present.
Okay. 72. 72
Present,
present.
ma'am.
Okay. 73. Okay. 74.
Present, ma'am.
Okay. 75.
Present, ma'am.
76.
Present, ma'am.
Okay. 77. Henzer. 78.
Yes, ma'am, 78.
Okay. 79. 80. 81. 82.
Present, ma'am.
82.
Ma'am,
83.
81 present.
81. Okay. 82.
Ma'am, 82 present.
Okay. 83. 84.
Present, ma'am.
Okay. 85. 86. 87. 88.
Yes, ma'am. 88 present.
Okay. 89.